Alright, so we are looking at 7D.4. Our master learning objective is, I can solve real-world problems involving angle of depression by applying trigonometric equations. So, this is almost exactly the same as our last video, it's just now we're looking at angle of depression. So, what is the angle of depression? The angle of depression is the angle, the downwards angle, from the horizontal again to the line of sight of the observer. So if we look here, right, here's my observer, here's the horizontal line, here's the angle down, right, and so here's the object. Whenever, so I should go to here, we have an angle of depression, and I was kind of like drawing a box, I'm thinking of it as the diagonal, because whatever the height is here is going to be the height is here. Whatever the width is here is going to be like the width of that there. Okay, so we can kind of look at it a few different ways. So let's look at an example. A lifeguard is sitting on a platform looking down at a swimmer in the water. If the lifeguard's line of sight is 8 feet above the ground and the angle of depression to the swimmer is 18 degrees, how far away is the swimmer from the lifeguard? Okay, so we're always going to start by drawing, for these ones, drawing a diagram, again, a right triangle. But in this case, it's going down. Okay, so here's the lifeguard, here's the swimmer, and again I'm going to draw in that box, okay, to kind of help us picture some things. So what do I have? The lifeguard's line of sight is 8 feet above the water, so the lifeguard is 8 feet above the water. That means this side over here is also 8 feet, right? Those are equal. And the angle of depression is 18 degrees. Again, this is our angle of depression. How far away is the swimmer from the lifeguard? Here's the swimmer, here's the lifeguard. I'm going down that line, X. Now it's exactly the same. Always start across from the right angle is your hypotenuse. Across from the given angle is the opposite. Between the two is adjacent. I need to use my hypotenuse and my opposite side. I'm looking at SOHCAHTOA. Right, it is the SO part of SOHCAHTOA. So sine of theta equals opposite over hypotenuse. So sine of 18 degrees equals 8 over x. Put it over 1, right, and we will cross multiply. So I have x times sine of 18 equals 8 times 1, which is 8. Since I'm multiplying x by something, I'm going to divide. 8 divided by the sine of 18 is 25, and we'll round it, 26. Why not? Feet. Alright, let's look at example 2. A pilot in a helicopter spots a landing pad below. If the angle of depression is 73 degrees and the horizontal distance to the pad is 1,200 feet, what is the altitude of the helicopter? So I'm going to draw my lovely, so here's my helicopter, here's the landing pad. The angle of depression is 73 degrees. The horizontal distance, horizontal is going across. What is the altitude? Altitude just means height. Okay, so that's like your vertical height. So that's what I'm looking for. Okay, again, I could draw this in over here as well. This is also 1200. This is also x, right? It's a nice rectangle with a diagonal through it. Okay. So then, right, across from my right angle is the hypotenuse. Across here is my opposite. And the adjacent. I'm using my opposite and my adjacent side. So I'm going to be using tangent here. So tangent of theta equals opposite over adjacent. Tangent of 73 degrees equals x over 1200. Putting it over 1 and cross multiplying, I have 1200 times the tangent of 73 degrees equals x. Times the tangent of 73 equals 3,925. And this is also in feet. All right, looking at our next example. A building is 480 feet tall. Sally's on the roof looking down at a penny on the ground at an angle of depression of 42 degrees. How far is the penny from the base of the building? Okay, so here's Sally. Here's the penny. So really, my building, right, that's Sally on the top of the building, and my penny is over there. Here's my right angle. A building is 480 feet tall. So both of those are 480. And the angle of depression is 42. Again, my angle of depression is always up in this corner. How far is the penny from the base of the building? X is here, X is also here, right? That rectangle is equal across. Okay, so then labeling OA and H, across from my right angle is the hypotenuse. Across from my given angle is the opposite. Here I have my adjacent. So I'm using O and A. Again, I'm using SOHCAHTOA. O and A is tangent. So tangent of theta equals opposite over adjacent. Tangent of my angle is 42 degrees. My opposite is 480, right? Can't see. Over my adjacent is my x. I'll put that over 1, and I'll cross multiply. So I have x times the tangent of 42 degrees equals 480 times 1, which is 480. I'm going to divide both sides by the tangent of 42 degrees. 480 divided by the tangent of 42 is 533 feet. All right, our last question. Example 4, a plane needs to land at O'Hare Airport. It is currently flying at an altitude of 4,000 feet. The horizontal distance between the plane and the airport is 15,000 feet. What angle of depression does the pilot have to use to successfully land the airplane at the airport? So again, we'll draw our picture. There we go. Sorry about that. let's try again. Draw our picture. Okay. The plane you signed at O'Hare Airport is currently flying at an altitude of, okay, so here's our plane, here's O'Hare. Again, remember, altitude is still just our height. Okay, so our plane is at our height here is going to be 4,000. The horizontal distance, again, horizontal going this way, is 15,000. What is the angle of depression? Okay. So again, I just need to start by labeling my hypotenuse, my opposite, my adjacent. So I have something on my O, something on the A. So again, we're going to be using tangent. Lots of tangents. Tangent of theta equals O over A. Now here my angle is my variable, so tangent of x equals 4,000 over 15,000. Remember, I need to get rid of that tangent now. When x is the angle, right, we don't cross multiply. I just say x equals the inverse tangent of 4,000 over 15,000. And then we can use our calculator. And the inverse tangent of 4,000 divided by 15,000 is 14.9. Let's round to 15 degrees. Okay? So it has to use an angle of 15 degrees. All right, that is it. Go ahead and work on D4, your last activity for KC7.